In number one, we have a piecewise defined function, and we just want to find these values of the function. So f of minus 100 is obtained by substituting minus 100 into this top expression, 5x plus 2, and that's because minus 100 belongs to this category. Minus 100 is less than or equal to 3, so we use the top expression. So we have 5 times minus 100 plus 2 minus 500 plus 2, or minus 498. All right, now f of 3. We evaluate f of 3 by substituting again into the top expression, because the top expression applies to x values that are less than or equal to 3. So now we're substituting 3, so we use this top expression again. All right, so that's 15 plus 2, 17. And now let's substitute in, let's evaluate f of 10. Now 10 fits into this category. 10 is greater than 3. So we're substituting into x plus 4, so that would be 10 plus 4, or 14. And number 2, again, we have another piecewise defined function, and we're just evaluating at these three values. So f of minus 10. Well, negative 10 fits into this category. Negative 10 is less than or equal to 1. Now, this is the constant function. It's actually this piece of the piecewise defined function is a horizontal, has a horizontal graph. It's the line y equal 4, which is a horizontal line. When we substitute in minus 10, we get 4. Okay, f of 1. Well, 1 fits into this top category again, because 1 is less than or equal to 1. Substitute in 1 into this expression, and we get 4. Now 20 fits into this category. 20 is greater than 1, so when we substitute in, we substitute into x plus 2. 20 plus 2 is equal to 22. Number 3, we want to sketch the graph of this piecewise defined function. So we're going to sketch the graph in two pieces, first to the left of 2 and then to the right of 2. So here we have a little grid. Now for x less than or equal to 2, we just have a horizontal line at height 3. So that would be here going up to 2. All right, here's the piece of the x-axis that we would, that is x less than or equal to 2. So just along here, up to 2, and including 2 because of this less than or equal to. So we're going to have a closed dot here. So there's our horizontal line. This is a piece of the horizontal line with equation y equals 3. All right, and now we want to graph the line y equal x plus 1. So let's substitute in 2. If we substitute in 2, we get 3. So the point 2, 3 is where this begins. All right, so this actually begins right here at the same place where this graph ends. So in this case, we're going to start right here, so we don't have to plot another point. And we're going to draw a line with slope 1, so it's going to go off something like this. Just to draw a more accurate graph, maybe I'll substitute in another point. Let's say we substitute in x equals 3, and we have 4 over here. 3, 4, so if that's 4, okay, let me put in the point 3, 4 on our graph. And let's just connect these. And that's our line. This is a piece of y equal x plus 1. Sometimes these graphs connect. Usually, however, they don't. Okay, now we want to graph f of x is equal to x minus 2 squared plus 1. So we're going to do this in stages. First we're going to graph y equal x squared. Alright, we know that this graph is one of our basic graphs, so we should be familiar with this one. It goes through 0, 0, and we know it goes through 1, 1 as well. Alright, now we always do the horizontal transformation first. So next we're going to graph y is equal to x minus 2 squared. Remember, horizontal first and vertical last. Alright, x minus 2 squared, well that indicates, since this is negative, that's a shift to the right. Okay, so from here to here, we're going right 2. Remember, a plus 1 is a shift up, but if x is replaced by x minus 2, that's a shift to the right. Alright, so everything is moving to the right 2 units. That means we're adding 2 here to these x coordinates and here. So 0, 0 goes to 2, 0. And 1, 1 goes to 3, 1. And then just more or less draw your graph. Okay, so that's y equals x minus 2 squared, and then we wanted to graph y equal x minus 2 squared plus 1. So now we're going to shift up 1. So that means 1 is going to be added to the y coordinates. Okay, so here we have 2, 0, and that's moving to 0.21. So there's 2, 1 on our graph. And this point is moving to 3, 2. So this is our final graph. At this point, I'd just like to add one more example, similar to the one we did before, but now I also want to find the x-intercepts. In the previous example, there were no x-intercepts. This one will have. So again, we're going to take y equal x squared, and we're going to go right 2, down 4. All right, so I'm going to graph this in just with one graph, because I want to do this quickly. So we're going to go right 2 and then down 4. So the 0, 0 ends up over here at 2 minus 4. Okay, and the point, so this is 2, and 1, 1 will end up right here at 3 minus 3. Now, in order to draw a more accurate graph, I'd like to figure out where this graph crosses the x-axis. So basically, we're finding x-intercepts. Now remember, to find an x-intercept, we put y equals 0. So that's what we're going to do here. So just put a 0 here. Okay, let's solve this by first solving for x minus 2 squared. So we have 4 is equal to x minus 2 squared. And now we're going to take the plus minus square root of both sides. So we have plus minus 2 on the left is equal to x minus 2. So that's two equations. 2 is equal to x minus 2, and minus 2 is equal to x minus 2. That'll give us our two intercepts. Here we have x equal 4 is 1, and x equals 0 is the other. All right, this did look like it was heading towards 0, and it is. So this does cross at 0, and it crosses at 4. That's what we figured out. So now we can draw a more accurate graph. We can make sure that the graph crosses where it's supposed to cross. 0 and 4. The following transformations of y equal x squared results in which equation? First, we want to shift right 2, so we're going to replace x with x minus 2. So we have y is equal to x minus 2 squared. Next, we're going to reflect through the x-axis. That means we're replacing y with minus y, or another way of thinking about this is we can think of it as negating the entire right-hand side. Instead of sticking the negative sign here, we can just stick the negative sign in front of the right-hand side. So we have y equal minus x minus 2 squared. Shifting down 3, so we're going to just subtract 3 from this whole thing. Okay, again, let's review these reflections, this reflection through the x-axis. Let me just review that. Reflect through x-axis. So y equal f of x becomes y equal minus f of x. All right, if we look at, here's the x-axis. Let's suppose that's y equal f of x. All right, and then this will be y equal minus f of x. Okay, so that's how we reflect through the x-axis. The following transformations of y equals square root of x results in which equation? All right, first we're going to reflect through the y-axis. That means replace x with minus x. Left 2, okay, that means replace x with x plus 2. So that would be y is equal to the square root. Here's where we have to be careful because of the negative in front. Don't forget to use parentheses. Okay, so it would be negative, parentheses, x plus 2. Down 3, we're just going to subtract 3 from the whole thing. I might as well open up the parentheses here. Okay, that minus 3 is the down 3. Reflect through the x-axis. That means negate this whole thing. All right, so let's do that. Reflect through x-axis. You're negating the whole right-hand side. Let's open parentheses here, and we end up with negative on the outside and a plus 3. Okay, let's graph y equal square root minus x plus 1 plus 2. So we're going to do this in stages, starting with square root of x. So that one we know, that's one of our basic graphs. All right, it goes through 0, 0, and it goes through 1, 1. All right, we're going to do horizontal first, so let's start with, let's do this first, x plus 1. Okay, so that means we're going left 1. Okay, when x is replaced with x plus 1, we go left 1. So that would be here. So 0, 0 ends up at minus 1, 0. And 1, 1 ends up at 0, 0, 1. Remember, we're subtracting. Subtract 1 here, subtract 1 here. All right, remember we do vertical last, so the next we'll do this. We'll do the reflection, reflect y. All right, so let me indicate from here to here we went left 1. And now we're going to do reflect y. So that involves replacing x with minus x. Here's the y-axis. We're just going to take this graph and reflect it through the y-axis. Let's imagine this piece first. So if we're reflecting through y, this x gets replaced with minus x. So this point here is going to go to 1, 0. All right, here x is 0, so that's going to stay where it is. So this piece is going to go, I'll just draw it like this lightly here, and this piece out this way when we reflect. So we end up with something like this. And then finally plus 2, so up 2, that's the last transformation. Add 2 to y, so this is going to go to 1, 2. And this point is going to go to 0, 3. Okay, and let's just draw our basic graph, our shape, shift it up here. And that's our final graph. In number 8, we want to know which of the following series of transformations of y equals square root of x results in this equation. All right, there should be a y equal here. Results in this expression here. And it says there could be more than one correct choice. All right, so let's try the first one. So first we're doing reflect y, so that is we're replacing x with minus x. So that's, oops, let me put the minus x in here. So that's reflect y. Left 1, that means replace x with x plus 1. Don't forget the parentheses. Okay, so what is this? This is, let me write it up here. This is the same as minus x minus 1. Up 3, we're going to add 3. And reflect x negates, puts a negative sign in front of this whole thing, negates the whole thing. Okay, so I'm just going to continue up here. So that would be minus x minus 1 minus 3. That negates everything. We didn't end up where we want, so this one's a no. Okay, let's do B. I think I'll do it down here so I'll have a little bit more room. So first I'm going to do reflect y. All right, and that means replace x with minus x. And now I'm going to do right 1. So I'm going to replace x with x minus 1. Let's open this up so we get minus x plus 1. Okay, that looks a little better because that's what we have here. Reflect x, that means a negative in front of this whole expression. So we're going to get minus x plus 1. Up 3. So we did that. Now up 3. Just add 3. And we do end up where we wanted to. So this one's a yes. B is yes. All right, let's try C. It says there could be more than one correct choice, so let's try C. Reflect y, replace x with minus x. Write 1, replace x with x minus 1. Don't forget parentheses. Down 3, that is subtract 3. So we did this one. Let's do down. Now we're doing down 3. Minus x plus 1 minus 3. Okay. And now reflect x. We're going to negate this whole thing. And we get minus x plus 1. And this minus 3 turns into a plus 3. So again, we're back where we want to be over here. So this is another yes. In number 9, we want to draw this graph, all right, and we're going to start with our basic function 1 over x. And let's remember that that has a vertical asymptote at y equals 0 and horizontal at, vertical at the y-axis and horizontal at the x-axis. And it goes through 1, 1, and minus 1, minus 1. We'll put in those 2 points. Really the most important thing in this graph is the vertical axis and the horizontal. We're going to be moving that, translating that. So first we're going to do horizontal first, so we're going to do left 1. Sorry, right 1. Minus 1 means right 1. Let me change that. Okay. X minus 1, that's right 1. So everything's moving to the right 1. That vertical asymptote is moving to x equal 1 now. The horizontal doesn't change. So this is what the graph is going to look like now. This 1, 1, we add 1 to the x-coordinate and move to 2, 1. Here also add 1 to the x-coordinate, and this is now at 0, minus 1. And then we just have to go down 2. So this is right 1. And now we're going to do down 2. So everything's going to move down. The vertical asymptote stays the same, but the horizontal is going to move down 2. So the horizontal is going down 2 from the x-axis to the line y equal minus 2. The vertical is still at 1. So like I said, the vertical and horizontal are the most important thing in graphing the translations of y equal 1 over x. We're just going to draw the graph here, nestled in between the vertical and horizontal, and here as well. Okay, so let's draw it in, and then we'll put in our points. All right, let's just put in these points. So here we move down 2, so we're going to subtract 2 from here. 1 minus 2 is minus 1. So this is 1 minus 1. Oh, sorry, we were over here. Subtract 2 from here. Still same. This is 2, sorry. That's 2. I'm taking this point, subtracting 2 from here. So we're at 2. 1 minus 2 is minus 1. 2 minus 1. And now here subtract 2. And we'll be at 0, minus 1 minus 2, 0 minus 3. So this is 0 minus 3. That's this point. And that's our final graph. Okay, so that's our final graph.